Hello, everybody. I hope you enjoyed the keynote and you chose your foundational session wisely. Welcome to the first breakout session here at TechEd in Houston. I want to thank you in advance for choosing to spend the next 75 minutes of your life here with me. I hope to make that a good return on your time investment. And as you can read on the slide, my name is Daniel Moth. Originally, I come from Greece. In Europe, and when I was around 20 years old, I moved to the UK, where I spent around 15 years, including working as a software developer for a few companies. And then around 6 years ago, I moved to the States, to Washington State, specifically in Seattle, to join Microsoft and the Visual Studio team. And that's where I am still now, on the Visual Studio Diagnostics team. I like to travel, so I was really excited when I was invited to come down here and speak, because I've never been to Houston before. This is my first time. In fact, I'm curious, by a show of hands, how many people this is your first time in Houston? Can I see that? It's quite a few. If you look around you, the people that didn't put their hands up, those are the ones you want to talk to for tips about what to do over here. And I happened to be in that situation, actually, around 3 months ago. I was doing an interview, trying to hire someone for my team, and they were actually from Houston, so they live and work here. So I took the opportunity and I asked them. I said, hey, I'm going to be in Houston in May. You know, what is it to do there? What is it to see? And he said, like, you're going to have a ton of fun over there. There's a lot to see. There's a lot to do. And I'm like, this is great. So tell me more. Like, what's the top thing? You know, what's the top attraction, the top thing I can do when I go to Houston? And he said, well, you can drive 2 hours to Austin. And it's an amazing place. I'm like, great. So based on that account, the best thing about Houston is that it's close to Austin. But joking apart, I've been here for a couple of days now, and I do like it, because compared to Seattle, where I traveled from, when you look up in the sky, there's this bright yellow, round thing. I think it's called the sun. So I like that already. And those of you that have been to Seattle know what I'm talking about. So I know you're not here to hear tips about Houston. You're here to see tips about the Visual Studio Debugger. And judging by the hundreds of you that have turned up, I don't think I need to motivate why this is important and why we should be talking about it. But I will anyway. So what I did is I went online and searched for quotes around debugging. And I found 3 that resonated with me. And I'd like to invite you to just take 20 seconds to just read them. Essentially, it boils down to this. You want to ship quality code fast. That's what you want to do as developers. And the debugger can help you by eliminating bugs, and it can help with the quality parts. But really, if you think about it, the less time you spend in trying to find and fix bugs, the more time you can spend adding value, adding features to the code that you ship. So being good at debugging is equally good to being good to writing code in the first place. Now, it takes talent and experience to be good at diagnosing root causes. And that I cannot give you today here. But I do know that if you take 2 equally experienced and talented people to try and find a problem, and one of them knows the tools better, that's the person that's going to find it faster. That's the person that's going to win. And that's what I can do for you here today. I can make you be that person that wins. I can make sure that you know more about the debugger, more about the tool than anyone else when you go back to your workplace, from your colleagues, your manager, whoever you work with. After this session, you will know more about the Visual Studio Debugger and how to make the best of it than any of those folks. And from day one, from your first debugging session, you'll be able to apply some of the things in order to cut the time you spend there. It's all about saving time, being a power user of the debugger. So that's what I plan to do here. Is that a good deal? Does that work for you? Yeah? All right. So how are we going to do that? We're going to do it like this. I'm going to spend 60 minutes in Visual Studio. So those of you in the back, there's going to be a lot of Visual Studio in code. I've got big fonts, but if your eyesight is not all up there, you probably want to move forward. There's going to be a lot of Visual Studio here. And at the end of the 60-minute demo, if we have time, because I like you already, I'm going to throw in probably 10 slides with 10 tips on each one. If we don't get to that, don't worry, when you get the deck, they're pretty self-explanatory. You'll be able to get those extra bonus 10 tips. So that's how we're going to do it. And before we go to the demo, let's start with 3 slides and 3 new things in Visual Studio 2013 to set up the pace before we jump into Visual Studio. So the first thing is just my code. How many people in here know what just my code is? Can I have a show of hands? It's very few of you, and that's fine, because by default, this just works for you, and you don't have to know about it as a .NET developer. The cool thing is, what's new, is that now C++ and JavaScript developers can also benefit from this in VS 2013. What it does is it basically hides code that you don't care about, because it's not your code. So we've got some rules that you can read up there about how we determine which code is not yours, so you don't have to have that visual noise there, you don't have to accidentally step into code that you don't care about, and all that kind of stuff. So it lets you focus and hence find the solution faster. You're going to see a bit of this in action when I go to the demo, but now we also support it for C++ and JavaScript. The second thing is the modules window. And I know that not everybody uses the modules window, but when you do need to debug something to do with symbol loading or with finding the right module, the modules window is indispensable. And we've now added a search capability. To be honest, we did not add this for you, although you can benefit from it. We added it for our own developers. This is what Visual Studio looks like when you attach to it. You see the little scroll bar? That's how many modules are in there, so search was pretty important. As an aside, following on from the previous slides, and since most of you said you were not familiar with just my code, if you're curious which part of your application in terms of modules we treated as your code versus not, you can find out by going to the modules window and looking under the user column and seeing yes or no, and looking at whether we thought it was optimized or the symbols were there and so on. So that's the second thing. We've got now search support in modules. The third thing is that .NET Framework source stepping now works. We've had this feature out for a while, but it wasn't really working correctly all the time due to the frequent releases of the .NET Framework without a corresponding source release. You can go to the URLs that I've got up there when you get the slides to read more about it. But do note, when you use this, you have to turn just my code off. So you're trading off that. I personally do not find this useful for my everyday debugging. I find it very useful for using the debugger, the best tool in VS, in my opinion, to understand how the framework is implemented, the .NET Framework, by stepping into the various methods. So use it as an exploration tool rather than a debugging tool, in my opinion. So those were the quick 3 things. And now let's go and have a look at Visual Studio. So I'm going to be using here a WPF application, but it doesn't matter. Most of the tips apply to all languages and other kinds of platforms. So a very simple app here. It doesn't do anything interesting. You can see I'm in design mode here. 2 classes is all we're going to be looking at. And when I run it up, it's just an app with big buttons. I figured today there's touch screens everywhere, so I'll make my buttons big. You never know when I'll want to use my forehead to touch a button, so I need a big target. Yeah, that's the level of jokes, by the way, we'll have here. You can cringe, smile, do whatever. So, so you saw there that I hit a 5 to start debugging. Hopefully everyone knows that. But did you know that you can actually start debugging just by stepping into your app? So you can go and hit F11 or F10, and you can step into, and that takes you out of design mode into debug mode on the first line of your code that's going to execute. So, and then from here, if I was to go and continue stepping, of course, it's going to go into the constructor of my class. It's hit my field initializer. And now it's going to hit the field initializers of this other class, and then I can step there. I don't have an explicit constructor here, so it's going to step back out, and then I step into this constructor, and so on and so forth. So let's talk a bit more about this tip. I won't do this for all of them, just so you can get the idea. So why is this useful? It's useful if you're trying to debug startup issues. How would you have done it otherwise? You would have had to go find what was the first line in your application that was going to execute, put a breakpoint, then hit a 5, hit the breakpoint, then remember to remove the breakpoint because you don't need it anymore for later, and you would have solved your problem. So what does this do for you? It saves you time. That's the theme. All of the tips I'm going to show you, there would have been another way to achieve what you want, but these save you time. So you can step to start debugging. Now, what I wanted to do here is I wanted to go into a function so I can show you some stuff. And that function is actually demoviz. So I could step into demoviz, and I want to go all the way to the end down here. So instead, of course, doing all that stepping, what can I do to just get to the end of the function? I put a breakpoint, right? But again, I don't want that breakpoint to stay there. So instead of setting the breakpoint, hitting it, removing it, what I can do is Control F10, which is run to cursor. So if I choose run to cursor, the execution just goes there. So you can see the yellow arrow, the instruction pointer, coming right on line 39. So when you know where you want to go, you can Control F10 while you're on that line, and the debugger will just reach that point straight away without having to set a breakpoint. So I wanted to get into this function so I can show you how we inspect things. So clearly, I can go and look at the locals window and inspect my variables. But what I can also do is hover over a variable and see what we call a data type. So I get a data type, and I can look at the data that way. And this is a string. So for a string, you see this magnifying glass. That's what we call visualizers. So I can go and click on that, and then I will get a string visualizer that lets me look at that text. So if it was a long piece of text, I would be able to kind of see it here with more screen real estate, maximize, and so on. And we have one of those for XML. So I can go on the XML and click on the visualizer, and now I can see this nicely formatted. So it really is human readable that XML is supposed to be. I can see it in this visualizer in that manner. We also have one for HTML, so I can go and click on that, and then we get HTML visualizer coming up, so I can see my string not as angle brackets, but as what it's supposed to render and debug things that way. Both for XML and HTML, we use the browser engine to render that for you. So you notice I'm just clicking on the strings on the visualizer icons, and because I've clicked on them earlier, before you guys came here, that's why I knew which visualizer to pick, because you have to choose what visualizer you want. And you do that by bringing the drop down, and here you can see the brand new visualizer that we added in VS 2013, which is a JSON visualizer. So now when you have JSON content, you can go and look at that, and here we have even search, so you can go and search for items, and we remember the history of your searches. So here's one I did earlier, and so on and so forth. So a JSON visualizer, a new visualizer you can take advantage of in Visual Studio. Now, when you have more complex types, such as a data set, and you hover over it, typically what you do is you go expand. So I can go here and expand, and maybe I'm looking for something specific. I'm actually looking for tables. I go here as the results that I want. It gives me the refresh icon, so that means the debugger is going to need to execute some code to get this back. So it's letting me opt into that in case there are undesirable side effects. I always click refresh. There's usually no side effects for me. So I go and expand that, and now I've got the authors table, and I could go browse that, and so on and so forth. So I've done all this clicking on the data tip and browsing and moving around, and I got it to the point I wanted. And now I realized I want to see something in my code that is being hidden by this data tip. Like maybe where I'm loading this data set from, or what name I gave it. Something like that is going to correlate to what I'm looking for. So I don't want to dismiss the data type, obviously, because then I'm going to have to go do all this browsing again. So what you can do is you can make it transparent by holding down the control key. So by doing that, it's now transparent, and I can look behind. If I let the control key, it's full, transparent, full, transparent, full. You can have hours of fun just doing this. It's not going to save you a lot of time, but you'll be happy. So the transparency is kind of like a cool thing, and that also works with the IntelliSense window, the statement completion. So when you're typing, you get the IntelliSense window. Control makes it transparent too. So now I found the item, its authors. Let's say this is what I wanted to go and look at. So I want to be able to look at this and look at other variables at the same time. So I could right-click and add it to the watch window so I can have it there all the time. But I like the fact with the data tips where my point of attention is in my code. So what I can do is I can actually use pinning. So you see this pin here at the end, and this appears wherever you hover, that pin on the right. So that is the clue, the visual clue that we hope you find, which is that you can pin these items. And when you click it, you get a blue pin in the code. So let me unpin it. You see there on line 29 where it says 29 to its left? You see the blue pin? That's where it's gone. So that means now I can dismiss this data tip, and I've got this pin data tip in my code that I can move around. So it's kind of creating my own scoped watch window here in my code. And I can go and expand on this and look at it further while looking at other variables. It always stays there. And what's cool about this is I can also go and add comments, for example. So I was here would be a useful comment, perhaps. And the reason you would do this kind of stuff is because you can go on the debug menu and you can go and export data tips. So then someone else could go import them. And now you've kind of done almost like a handover of your debugging session. It's like, I found these interesting values here. Why don't you take over now and kind of keep going to it? Or as a reminder to yourself if you want to come back to it. And these pin data tips, when you stop debugging, they're actually still there. So you see the pin. And if I go and hover over it, the data tip appears again. And it shows me the value from the last debugging session. So you can actually see the values even after you stop debugging, which you can't otherwise. So let me start debugging again so I can show you more things in this function. By the way, that control F10 that we did, run to cursor, you can also start debugging like that. So you can just hit that, and our debugging starts and takes me right to that line, which is where I wanted to focus. So a double tip there with run to cursor. I've got this data table here, and notice that it has a visualizer as well, which is actually the same thing that the dataset itself has. And if I click on that, you get how you would expect to see your data in a visualizer that's like a table. And if I have multiple tables, I'd be able to switch between that. So the dataset visualizer, if you use datasets, can be useful in that way. Now let me show you something that when I saw it blew my mind. Did you know that you can actually get these data tips from comments? So I can go here on this comment on the path and hover over it, and now I can see that. So that means you can leave comments with useful expressions or whatever in your code, and you can go hover over them while you're debugging without having to have those variables in the code itself. Again, kind of creating your own watch. And it means you can even do it on the fly. You don't even have to think about it ahead of time. I can go here and just type a comment straight away and say, I plus j. And then when I go and select that, I can actually see the value. So while you're debugging, you don't even have to go and expand and do stuff. You just add comments. How cool is that? I like that. So speaking of looking at data tips from comments, if I look at the this, that is obviously going to be my WPF elements, and I can go and expand here. And that big button that we're seeing earlier, that's what I've called here but it's not for the kicking. And I have the visualizer of the WPF tree visualizer. So if you have WPF elements, you can also go and look at this visualizer, which shows you on the left your visual tree, and then on the other side, the properties for the selected item. And you can filter and search on both of these sides as well. So these visualizers that I've shown you for the data sets and the WPF and the string visualizers, you can also write your own for your own objects. So that will help your debugging be better. It's very easy. You can read the online MSDN documentation. If you're providing libraries to other people, you should definitely write visualizers for them, but even for your own debugging of your own code. And I think with that, we're going to call that part of the demo done. So what we saw there was how you can start with stepping, how you can do run to cursor with control F10, the various visualizers, data tips, including getting transparency, pinning them, getting them from comments, and I talked a bit about function evaluation when you hit the refresh icon. So that's the kind of stuff that I'll keep showing you. Does that work for you? Is that good? Yeah? All right. Let's go and look at the next thing. So back in the app, I'm going to continue. And I've got these buttons, so I could click any of them, but I actually made the label clickable for some reason. So we're going to click on the label where it says Spot. And when I do that, notice how the title of this window is Moth Window. It's going to change. So I click on it, and it changed, and it says A, B, D, C. And let's assume I was expecting this to say A, B, C, D. So what I need to do is go debug that. So what you would normally do here is just go into the event handler for that label and put a breakpoint and debug it. And that's what I'm going to do. But I just want to show you something else while I do that. Right here, and instead of putting a breakpoint and reaching this point, I can also, again, start, in case you haven't realized, run to cursor is my favorite feature, with control F10. And even though it's not on the startup path, so we're not hitting that place, it is really a temporary breakpoint that we put there. So now when I go and click on the label, that's going to break at the right place. Right? So run to cursor, just take advantage of that. So here I am on line 73. And we all know that if I do an F10, a step over, it's going to go to line 74. If I was to do a step into an F11, it will basically be a step over since I have no function on this line, hence there's nothing to step into. So I'm going to do that, and I'll get here. Fine. Now if I do a step over, F10, it's going to go to line 75. But if I do an F11, a step into, which one of these functions is it going to go to? You have like, you have code, you have rights, you have who, even title. That's a function you set in, it's a property setter. So which one of these is going to go to? I'm curious if you know. I hear a lot of like. Anyone for any of the others? So if anyone was thinking any of the others other than like, you'd be wrong. There's no sugarcoating that. Like is the next thing that's going to execute, so that's the right guess. Of course, you were wrong as well with like, but that's because I tricked you. That was the right answer, but it's wrong in terms of what it does. So let's see. When I go and I'm going to step into, instead of going into like, it stepped into get A, which is not even anywhere on that line. So how did that happen? So every time you land somewhere, maybe it's an exception that breaks you under the debugger, or you stepped whatever, and you land somewhere, and you're like, whoa, how did I get here? What do you do? Which window do you use? The call stack, right? So that's the window you want to go and be looking at. So here in this window, it tells me that the previous line, the previous code that was my code is here on grid mouse up. And then it says the next my code is get A, where we stepped. And in between, I can see this annotated stack frame, as we call them, which is an external code. And I can see external code below it. You never probably noticed it below it because you don't care. As far as you're concerned, the first thing they executed was that event handler. So if I go and show external code, so you can right-click on the call stack to show external code if you want to briefly look at stuff, you'll see the kind of goo that we hide for you down here. Like there's a lot of code that's just not your code. That's just my code in action. That's what we also brought to all the C++ and JavaScript guys. So back to what we were investigating. Indeed, like is in between here, but it's showing grayed out. It was part of the external code. So how did that happen? Well, let me turn off show external code, because that's the way I usually like doing that. And if I scroll up, you'll see how. So on like, I've used this attribute called debugger non-user code. So if you want to take functions in your code where you think, that's something I will never need to debug. I don't need to land here ever. It's very simple. You can just put this attribute on, and we'll treat that also as external code. And if you're thinking that you probably want to go and do that on many of the properties, which is the simplest code that you typically don't need to debug, we've got you covered that on already with regards to stepping, because you can see step over properties and operators is by default on. But you can turn that off if that was something that was annoying you when you were stepping and you wanted to go into your own properties and operators. So that's how we did that. So now let me go and step out. So Shift F11, I'm back in here. Now when I do F11 to step, we're of course going to go into code, right? So there's no tricks here. We're into code. I'm going to Shift F11 again to step out. And now I'm going to F11 again, and I'm going to go into writes. And remember, I'm trying to figure out why I'm seeing on the title ABDC rather than ABCD. And I think I found the bug. Can you see it? So basically here, the value of P is what? It's AB. And you don't have to hover to see that. It's right there in the locals window. And also notice you can see it in the call stack window. It's as part of the argument there. Now, in your installations, you're probably not seeing it in the call stack window. The way that you turn that on is you right-click, and you choose Show Parameter Values. So there's a bit of a performance impact that can be when you do that, but I always trade features and productivity for the performance of the debugger, so I turn this on all the time, and I, in fact, turn off types and names, because I personally don't usually find those useful. So you can configure what you see as part of the stack frame display in the call stack window. So indeed here, A and B, that's where we're going to go and add D. So I think I found my bug. I'm going to step out and then step in one more time to confirm. Yep, indeed, here's where I go put C in the end. So somewhere here is my bug, and then I'll go and step back out. And now when I go and step into, where is it going to go? Which line or which function? You can be brave. Where? The title, right. So the title is on the WPF element. So that was wrong, but thanks for playing. It's not going to go into the title because that is not your code, right? That is not code that you wrote, that property. So it's not going to go in there. So instead, when I go and step into, it's going to go to the next line. So we found here, I'm close to how to fix this, and I can go and do that. But I want to show you another way we could have done this exploration, which is fairly typical, not with simple code like this, but in terms of the flow, and how you could have done that faster. So in order to show you this faster way, I want to re-execute line 74. So what normally people do here is they go and stop debugging and put the breakpoint again and start again and execute again. And sometimes you've done all your path in your app to get to the right point, and you're like, I just want to execute this line again so I can see something. And you don't want to go all the way back. So what you can do is you can use my 5th favorite feature in Visual Studio. I have them listed, which is set next statement. So I can right-click here on line 73, and don't confuse it with show next statement. If you go and choose set next statement, we're now going to move the instruction pointer from line 75 to line 73 where I clicked. So we've moved that back, and now I can continue stepping from here, and I can go and step over that line. Now, bear in mind, we haven't done any magic here. We haven't reset the process state or anything like that. If there were any side effects from line 74, you now are susceptible to them. So maybe there's something set something to null, and now I would get a null reference exception. So only use this when you know you can indeed re-execute the line of code. So here in line 74, was there a side effect? There was, right? I changed the title. Does it matter? It doesn't. I can go and set it again. But let's say it mattered. If it mattered, then I would use here my seventh favorite feature in Visual Studio, which is actually to go and right-click on these things, and you can go and edit the value. Or you can hit F2 on the data tip, or you can just go and click on it. So if I click on it, I can go and change this, so I can make it what it was before in case that mattered to me. And now that value has changed, and I can go and re-execute it. This edit value is very useful also for testing different hypotheses. Like, oh, if this variable was like that, what would this code do? And you keep changing in the debugger rather than going and writing code to change your initialization and so on. It's a quick way to hack around. So from here, now I'm going to go and step into. And let's say that when I reach this point, remember we're trying to solve this bug again, I had a hypothesis in my mind that writes is probably where the problem is. So I want to go and step into that. So what you could do is you could say, OK, I'll do a go to definition, an F12 on writes, then go put a breakpoint, then continue. But you can do it faster. If you go and right-click here, you can actually see step into specific. So we show you this when we detect multiple function calls on a certain line. So when I see step into specific, I could go, it even gives me the title set. And if I try and click that, it's going to say, hey, you've got just my code on, so you can't step into there. So I'm not going to do that. But from here, I can go and pick directly the function that I was interested in, which maybe was writes, maybe was who, and I can go straight there and actually validate my hypothesis and inspect without having to step everywhere else. Is that cool? Yeah? All right. So let me step back out, and I'm going to show you an even better way I would have started this investigation if I have VS 2013. So I think all of the stuff I've shown you so far, minus 1 or 2, are in all the Visual Studio versions as well. So what I'm going to do is I want to re-execute this line of code. So I'm going to use my favorite feature of set next statement. You don't even have to right-click for that. You can just drag the yellow arrow up. So you just drag it wherever you want. You could even, as you're approaching somewhere, you're like, oh, I don't want to execute the next statement. And then you'd be able to just take it and jump over that, and then continue debugging from then on, right? And then you can come back later and figure it out. It's so easy to move this thing. Sometimes I just move it just for fun, even if I don't need to. So again, just wasting time. I'm gaining so much time from my productivity tips I wasted elsewhere. So here's the thing I want to show you. So on this line, we have multiple function calls. And they're all going to return something. And people do write code like that. I write code like that. We all do. I mean, the debuggable way to write this would have been to put temporary variables for each one of the return functions, so then I could see them right there in my code, right? But I haven't done it. So what you can do in VS 2013 is use return values. And this has been available in C++ for a while. So if you write in C++ code, you can use that there already. What return values does is when you step over a function, it puts in the autos window the return values for all the functions on that line. So I'm going to step over, and you can see here in the autos window what each function returns. So just by looking at that, I can immediately see where the problem is. Writes returned ABD, and now I would probably, given that clue, go back to the previous line and then do a step into specific and go into, I keep going to the wrong one, and go into the function and go and fix the issue. So that's probably a flaw with a followed with these return values. And notice these return values are not just for your functions, so they would show even for function calls to frameworks. If you call to string or anything like that, you'll see that in the autos window. So here, when I step over this line, P plus D, under the covers, what happens when you're trying to add strings like that? Well, it's generating the string concat. Under the cover. So that's where I can see here that string concat returned A, B, D. So it works kind of everywhere. I really like return values. So that's, I think, the end of that little flaw over there. So again, let's have a look at what we saw. So we looked at the call stack, how you can show external code by right-clicking on it and turn on the parameter values. We looked at the attribute debugger non-user code, if you want to hide your code from the debugger in that way. Set next statements, really awesome, and edit values so you can play with stuff that way. All the various stepping things, including step into specific, and the new feature we've added, manage return values. All right. Back to our demo. So how many times have you written some code and you haven't completely integrated it into the rest of your code base, but you really want to debug it and test it using the debugger? So you don't want to do all the hooking up. You just want to quickly just test that code. And if you're like me, what you end up doing is you're probably going and creating a new project and going and testing there this new API or whatever, make sure it works, then you bring it back into your project, then you go and hook it up. But actually, there is a way you can shortcut that by using the immediate window. How many people here knew that with the immediate window you can start debugging? Can I have a show of hands? That's very few. So I think the rest of you will appreciate this. So what we can do here in design mode, I can go in the immediate window. I can just start executing code. So I can go and say var o equals new my class. And when I hit enter, that went and executed code. And now there is this O in memory that points to my class, and I can even see the values for some of its properties evaluated for me. And what I want to do is I want to go and test one of the functions down here. So we'll go and test reverse string. So here's the reverse string function. And notice here I have a breakpoint. If you didn't know that, you can actually use debugger.break. It's exactly like a breakpoint, but it's always in your code. So if you ever need that, you can go and use it. So I want to test this function, so I'm going to go here and say O. And I'm going to put here a string to go and test reversing, and then we'll see how we're going to hit the breakpoint from design mode, testing this isolated function in this class without going through the normal startup path of our app. I think this is really cool. So let's test this string and see how that reverses. So I'm going to go hit enter, and there we are. We just entered debug mode for a specific isolated place from design mode. Really cool. So that's how you can use the immediate window, and if you go to the locals window, you can see $O, which are all the variables that you declared there in your immediate window. You can go and look at them in the other watch windows, you can query them there, and so on and so forth. So while we're here, let me show you my third favorite feature in Visual Studio. How many people here know about trace points? I can count on one hand the people that put their hand up. So trace points, this is awesome. You're going to love this. You're going to break into spontaneous applause when I explain this to you. You can practice now. No, it's fine. So when you put a breakpoint, we all know how to put a breakpoint. Did you know you can right-click on these things? And when you right-click on them, there's a whole bunch of additional options that open up for this fundamental piece of debugging, this is the breakpoint. And one of them is called when hit. So when you choose when hit, you get this dialog that allows you to customize and print a message from the breakpoint when it is hit. And you can read on the dialog the kinds of things you can put in here. So I can go here and put revstr. And when I put that in braces, what I get is the value of revstr. So that's what I want to go and see here in my recursion function. But furthermore, I can go and check the continue execution, which by default was checked, you will have noticed. And what that will do is it won't even break. So I won't even have to hit that breakpoint and continue. It will just output to the output window whatever I've put in the message. And in the message, I can include things such as the call stack, the caller, the function name, thread ID, all the kind of different pseudo variables that we have here in the debugger. So when I go and hit OK on that, you see that the breakpoint has changed to be a different shape. So I've got a diamond instead of a round shape, indicating this is a trace point. So with this trace point now, when I go and continue, what's going to happen? Well, here I have recursion. So reverse string comes in, and then it calls itself multiple times. You can see that on the stack as well. And so we're going to see the output, the intermediate output of every one of those recursive calls. And then in the end, we're going to see the actual value. So when I go and continue here, we see here actually in the immediate window, since that's where I started debugging from. Oh, put it on the wrong line. Let me show you another debugger feature since I've done that mistake. What I want to do now is I want to move the trace point from line 87 to line 88. And of course, I don't want to just remove it and put it there because I've done effort to put in the customization in there. So I can go and choose location, and then I can just say here line 88, and that's how you go and move breakpoints. And now if I run this again, I actually have that hooked up to this button. We're hitting the breakpoint, and now when I continue, if you look in the output window, we see the reversal of TechEd as the revstr that came out from that trace point. So to make super clear, everyone kind of gets this. With trace points, you can do the same as debug right line, except you have all those extra pseudo variables that you can use. You can do it while you're debugging, so you don't have to, while you're debugging, think, oh, I want to output this. Now I've got to stop and go add the debug right line. And by having trace points, you don't have to litter your code with debug right lines you've used for temporary debugging sessions and then never removed it. So it pollutes your code base. And the next time you really want to look for something, you've got all this noise from other kinds of things. And that's why trace points are really, really cool. That was the cue, yes, yes. I had to beg for it, but I got it in the end. So, and we never saw the never, odd, or even. Oh, here it is, actually. We saw the result for that. So never odd or even is never odd or even. So let's go and look at something else. Oh, we haven't got it anymore. Fine. So go back to the slide. So what we said there was the immediate window, how you can start debugging from that. I also showed you debugger break for the breakpoint, and the super useful third favorite feature for me, trace point. And I didn't show you hit count breakpoint. I'll show you that in a minute. But I did show you how you can use the location to change where a breakpoint exists. So how are we doing for time here? All right. Now I'm going to show you something that nobody else will know. So you know how sometimes you got some features, some people know, some people don't. This one, nobody in this room will know. That's what I'm asserting. So if someone knows it, when I show it, you say, I knew. Just say that. So we're going to go and hit that breakpoint again over here. And previously, I showed you how, in order to inspect state on each one of these recursive calls without having to break, I use basically output, debug right line or the trace point. But of course, I can see from each one of these recursive calls on the stack, I can see the value of the parameter. So I could compare the str parameter across these. But if I want to look at other variables, I have to go to the locals window and I have to switch between these stack frames corresponding to the recursive calls. And as I switch, I can see the values of first and last and so on. So does anyone know, if I wanted to debug some recursion, I don't have a bug here, but if you had some bug and you wanted to see which recursive call is the one that has the issue based on some data, how would you compare these variables across all these recursive calls? Like I can for parameters, but for all the other variables. Does anybody know how you can do that? I was right. Nobody knows this. So you won't use it every day, but when you have recursion and you want to look at this stuff, you can use a new debugger window we added in VS 2012, and obviously exists in 2013 as well. So I want to go and open this new debugger window. And by the way, whenever I tell people, hey, go and find this debugger window, people usually go on the View menu for some reason, where there's a whole bunch of windows from Visual Studio, but none of the debugger ones. The debugger windows are not here. The debugger windows are under the Debug menu. I thought I'd share that because you'll be amazed how many people don't actually find that first time. So if I go here, Parallel Watch, and we've got 4 of them just for fun, if I go and open the first one, what you're seeing here is each row is obviously on the same thread, and you can see the recursion depth. And from here, I can go and switch between the various stack frames, the various recursive calls, just like I could in the call stack window. But in addition, you see where it says Add Watch? I can go and add a variable, and then I can see that variable across all the various recursive calls. So I could go here and put first, and then I'll be able to see that and see that down here in the end, the name first doesn't exist for that particular stack frame. So you can find kind of the odd one out kind of situation. I could go here and put last, and so on and so forth. So that's how you can go and compare the values across multiple recursive calls. The real reason we added this window was for multi-threading, which I'm going to show you soon, but it also works when you have recursion. So when you have recursion, consider using this window for comparing stuff. So that's the Parallel Watch window. So from here, what I want to do now is I'm done with this recursion stuff. I want to get to where I'm calling it from, which is Revit. So I've got all the reverse string, and that was called from over here. Now, what would happen if I was to place a breakpoint here on 77? Would it be hit? Yes or no? No, right? It's not going to be hit because we're executing that line already. So execution will continue wherever it goes, and then on the way back, my breakpoint will be ignored, and it will just continue forward. So do you know how I can put a breakpoint there to say, hey, I actually want it to stop when it comes back? Someone must know this. You can put a breakpoint on the next line, but what you can actually do is you can use the call stack window. So in the call stack window, there's a breakpoint option. So when you place a breakpoint from the call stack window, one of the stack frames, it's actually going to break on return. So you can go and put traps in various places. You can say, okay, I've reached this point. I want a breakpoint here, so when I return, if something goes wrong and it returns, I want it to stop here. And maybe from there, you would like reset the statement or something like that. So you can put breakpoints. But what you can also do is use one of my favorite features that I showed you earlier, run to cursor, if you're just doing it as a one-off. So if I do run to cursor here, it's just going to unwind. So you see that call stack continued with all its recursive calls and came back to that location. So that's another thing you can do. In general, just right-click everywhere, and you'll find all these hidden gems. So let's switch to something else. How many people use a wait and a sync? Can I have a show of hands? That's a few of you. And do you use, how many of you that put your hands up do not have VS 2013? You're using an older version of VS 2012. Oh, that's a few as well. So I'm very sorry. So what happens when you use a sync and a wait, which I've gratuitously used here, is if you land in one of these functions, again, due to an exception, a breakpoint, whatever, and you want to say, how did I get here? And you look at the call stack window in an older version of VS, all you would see is where you are, and then the annotated stack frame resuming a sync method. Maybe you'd see external code, and that's it. Because when you use asynchronous code, that's the call stack. We don't have the rest of it. That happened earlier. It's not actually active. So what we did in VS 2013 is we added support to show you the logical call stack for async operations, which includes, as you can see here, where we came from. So it was here that we used that wait to call that function. And in the call stack window, you can see our annotated frame async call that indicates, yeah, you're making an async call here, and then some external code got executed, and then your async method resumed, and that's how you ended up over here. So this is, without this, I don't know how people debug the async code. So I'm sorry that we didn't have that earlier when we released the language feature, but we have it now. And we have it across all project types and all three languages, so for JavaScript promises and C++, PPL tasks, and so on. So support for async in the call stack window, something for you to take advantage of. All right, what shall we see next? How many people know about make object ID? OK, you're my crowd. All of these are new tips for you. So make object ID, what does that do? Well, over here we have, on this stack frame that I've switched to, rev_click, I can see this reference, which points to my main window. Let's say I wanted to keep track of that, so I'm going to take it and put it in the watch window. So when I click add watch, from the locals window, it goes over here. Now, what's going to happen when I switch back to Revit? What's that this going to point to then? It's going to point to my class, right? Because this is in a different place. So the variables in the watch window bind to the current context wherever you are. So if you want to see pieces of memory, variables that are across stack frames, across execution contexts, and they are not in the same scope, you don't have the variable, then it's tough to do. So that's the reason that we have support for make object ID. So instead of switching here between these stack frames, if I want to always have access, like the address in C++, it's similar but obviously not the same, I want to have access to this, what I can do is I can make object ID. And here where the value appears, you're going to see there, when I make object ID, the £1 appear. If you're English, that's a 1 hash, American £1. So we'll use £1. So here I can go then and use that, and I can say £1, enter, and now I have a handle, essentially, to this piece of memory. So no matter where I switch to, what stack frame, how my execution context changes, threads, and so on, I can always look at the value of that variable. So I could do the same if I go and switch to the other one, make object ID of this guy. Now we're going to see 2, because I've made the second one. So that's £2. So I'm going to go do that. And now I've got a reference to that. So no matter where I am, I can always now see these two, and I can keep track of them. So there's various uses you can use with this, but if you ever wanted to be able to look at the memory regardless of the variable being in scope or not, this is the way to go do it. So that's make object ID. Now, another thing I'm noticing here, just switching to another tip here, with is debugger visualizes, the display visualizes. So here I can see that my class, it just shows me my class. So if I wanted to see something interesting, some interesting state about this object, I would have to expand, and then I can see here answer 42. And I can see the guess and so on. So let's say answer is what I cared about. So I could go right-click, and did you know you can add watch from the watch window itself, which means that now I've got a direct first-class reference to that location. And then maybe for main window, what I really care about is the title. So I could go and expand the base and try and find title, and then right-click and do add watch on that, and then go and collapse everything. So it's a bit tedious for me to get to the two pieces that I cared about. What I really want here is a way for me, whenever I have a reference to main window, my choice is I want to see title. And whenever I want a reference to my class, I just want to see answer is 42. That's what I care about when I'm debugging these types of objects. So that's what I would want to do. And I wouldn't be saying that's what I want to do if there wasn't a way to do it. So there is, and I'll show you that now. So what you can do is you can go and override to string. And when you do that, Control-KU to uncomment, then whatever you return from that to string, that's what's going to appear in the value column every time you look at that object. And for my class, I'm going to do it differently. The other way you can do it, if you're using the string for something else, so you don't want to override that, so the recommended way is to just use the debugger display attribute. And if you have both, the attribute wins. So now if I go and start debugging, and let's go and do the same thing, and we'll get to the same place. And notice that this, which now points to my class, says the answer is 42. And if I switch to the other window, you'll see that this, which points to main window, says title equals moth window. Also notice those object IDs are now invalid. The memory has changed. We just stopped and started. So these are only per debugging session. So if you wanted to have those watches work again, you have to remember the order you did them, which I think was this order. And then they will just light up again. So you have to go and remake your object IDs, and then they will come on board. So that's how you can go and see whatever you want here. And furthermore, if you don't have access to the code for reference types you care about, maybe the .NET Framework types, maybe third library, you can't change the code. You can still customize your debugging session. So you can go and find on your machine AutoXCS, which is in your user directory under Documents, Visual Studio Visualizes. And in here, you can go and add your own debugger display attributes with a target. And then in the target, you can put the actual type that you care about. And you can customize its display the way you like it. And you see we've done this for some, but not nearly enough of the framework types ourselves. So if you're a library author, definitely put debugger display attributes. And even if you're debugging code, use this to save you some time so you don't have to do all that expanding and adding watch. So let's see. I think I'm going to show you my 6th favorite feature now. Yeah, let's do that. So let's go and hit the spot button. And we hit another breakpoint. And then in this breakpoint, I have a bug. And can you see what the bug is? It outputs wrong, and I want it to output cool. So there's this condition, for some reason, didn't turn what I wanted it to be. So just by looking at this, I can see, OK, guess, that's 7605000. Tot MS is 0, so that's clearly where my problem is. And then when I hover over the data tip, oh, that's total milliseconds. What did I use? Transparency, I use milliseconds. That's where the problem is. So I can go here, and instead of stopping, fixing it, and starting again, I can just edit and then continue. And the feature is called edit and continue. So with edit and continue, you can change your code and continue. And in this case, continuing will continue debugging further down. But I want to run this again to validate it. So I'll use my 5th favorite feature, which is to just move this, set next statement. And now when I hit continue, I'm going to see in the output window, oh, I'm seeing wrong again. So clearly I was too quick to think I fixed it. So that's fine, and that's fine. Oh, this guy isn't fine. So now, before I go and try and fix this, because I've been bitten once, I thought I fixed it and I hadn't, I want to validate my hypothesis without changing code. So that's where we use the 7th favorite feature, which is to edit value. So I can go and say, if this were true, would this have worked? So imagine a more complex condition. Then we go and set the next statement again. Now I continue, and now it says cool, so I know that would fix it. I still have to fix it, of course. So what I can do is go to definition of this guy to find out where he's being used. So go to definition is F12, but we have a new feature which works regardless of debugging called peak definition, Alt F12. And when you do that, that actually brings in line to where you are, so you don't lose your context, in line to where you are, a mini code editor that you can go and look at. So I can say, oh, some other condition, I just initialized the false, and maybe I think the right thing would have been true, so then I can go and change this to true, and now I get the purple underline, which is very disappointing. So what that is saying is you cannot edit and continue with fields and field initializers. So edit and continue has its limits. So this is an edit that is not allowed, which means that if I now try and continue doing anything with the debugger, I get the dialog that says basically, hey, you've made changes, you need to restart here, we cannot continue. It says edit, what it really means is go back and undo whatever you did if you want to continue debugging. And by the way, this restart, that's a tip of its own. Anytime you find yourself where you're in a position where you want to stop debugging and start, that happens quite a bit, you're like past the point of interest, don't just stop and start again. Go and hit the restart button, and that's going to be faster. So Control-Shift-F5 will just do the stop and start for you in a faster manner. So that's not what I want to do here, because I want to show you yet another tip. So I'm just going to stop debugging, and I will actually go to definition on actually this guy. So guess. You notice how guess had a value? What if I don't know how it got a value? What would you do? You're like, I don't know how this thing got its value. Anyone know? Find all references? That's a great answer. So that's what you would do, find all references. What would you do before that, probably? I would do go to definition, but find all references is acceptable. I would go here, and then I would do a find all references. And then I would find, let's say, 30 places where I'm writing to this. How do I know which one, in particular, for that debugging flow, was the one that was writing? Any ideas? Breakpoints? I heard breakpoints. So if this was a normal property, not an automatic property, that would have been exactly the answer. You go and set a breakpoint in the setter, and now, as long as you're clean with your code, you're not writing directly to the backend field, you would get there. Unfortunately, we do not support breakpoints on automatic properties. The CLR team is aware of that, so the more we tell them, the more they'll work with us to make this happen. But for now, we don't support it. So what we can use is we can use a function breakpoint here. So function breakpoints have value outside of automatic properties, but I'm going to use this as an example. So what's a function breakpoint? You can go to the debug menu, and you can say new breakpoint, and you can choose break at function. You can also do this from the breakpoints window. So in the breakpoints window, you can say new break at function. And then you get this dialog. And you may be thinking, well, all those breakpoints we were putting, weren't they in functions? And they were. But those were location breakpoints, because they were specific to a particular line of code. With function breakpoints, you actually put a function, and then we'll place a breakpoint at its entry point. Now, why is that useful? If you have multiple overloads of functions, so the same function multiple times, and you choose this approach, we'll insert a breakpoint at every single one of those overloads. So that's a nice little shortcut. But where it's really useful is for putting breakpoints in code you don't own. So you could go and put a function breakpoint in a .NET Framework function. You could put it in console or writeline or the thread creation or anything like that. And then we would break when your code calls that, and you'd be able to see on the stack where you called it from. Now, for that, you'd have to turn on just my code, but that's where this would be useful in that context. For C++, you can put it on heap alloc, for example, and then wherever you allocate memory from your function, we will break and show you that's where you're calling that. So that's function breakpoints, which is kind of useful and so on. I'm going to use it here as a workaround for my automatic properties problem. So I can go here and say my class.set, because that's what happens under the covers, yes. I'm just going to copy that. And when I go and set that breakpoint, IntelliSense says I can't find it. And I'm like, yeah, I've done this before. I know what I'm doing. And then I can see in the breakpoints window the function breakpoint set. There's no clue of it in the editor. It's a function breakpoint. It's not bound to a specific location that I can see. And then what I also want to do here is I might as well set a breakpoint on when it gets accessed. So instead of set, here I'm going to use get. And in fact, for when it's accessed, I don't want to break for that. That's not as critical to me. But I would like to see a message about it. So what can I do? I can right-click and combine it. So all these advanced breakpoints we have, they're all combinable with each other. So I can go and say, this is a function breakpoint that I'm going to make into a trace point. So here I could go and say, called by caller value was, and then guess. And I'm going to continue execution. So now I've changed that into a trace point. So now when I go and start debugging, immediately it breaks. Oh, that's where I was calling it from. When my window gets initialized, I forgot about that. And then I can go and look in the call stack, and I can see it's external code above me, because that's the setter to that property that I don't have really access to, and this is where I came from. So now I know where I'm going and setting that. And if you look at the breakpoints window, it shows you in bold always the breakpoint that caused the break. So that's a nice little tip there. And also in the breakpoints window, you can go and see the hit count of breakpoints. So for any breakpoint, this works. You can go and see how many times it was hit. So this one was hit once. I can see above the breakpoint I set on the getter has not been hit at all. So no one tried to access this. So now if I go and continue, and I go and hit that button, and we look at the output, we'll see cool, because we had fixed that bug. And here's the output from the trace point on the getter, which is called by, and here's the caller, so it tells me which function called it and what the value was. All right, so again, trace points in action showing you their value there combined with function breakpoints for automatic properties. All right, so let's see. I think that's probably all I wanted to show you here. I guess I should mention, since I mentioned hit count, when you right-click on the breakpoint, that's another option, hit count, and that's when you can go and choose the hit count to be equal to a number or multiple of or greater than, and then it would break only then. And again, why is this useful? It just saves you time. If you've got a loop and you're like, it's the 8th iteration or the 26th where the problem is, you say the hit count breakpoint was 26, you'll just break then rather than a 5, a 5, a 5 as you break all the time. So those are the hit count breakpoints. And with that, we'll go back to the slides and see if we've covered everything. So we saw the end and continue and the peak definition. We saw restart, function breakpoints, hit count breakpoints, all of that stuff. So that's the end of what I call the core tips. And we're going to now move and see some multi-threading stuff. How many people here do multi-threading development? OK, that's many hands, so you guys will be interested. So let's go and have a look at that. Same app. And this time when we start debugging, I've still got my breakpoint. You see what I mean about breakpoints? You never remember to remove them. And you hit them the next time. And then we continue, and then we go and hit the power button. And now we're in a place in my code. Now, what I want to do here for this multi-threading demo is actually go change my window configuration. And I don't know if you've had this feeling. Sometimes you're debugging something, and you would just like all kinds of different windows to come in. Like, I don't care about the call stack window here or the locals, for example. But if you close them, then you've lost them from the next time. So I don't know how many of you know we have a full screen mode. It's its own configuration. So if you actually go and do Shift-Alt-Enter, you see this goes full screen. If you have never seen full screen, what you would see on your machines is just a code editor, nothing else. But what you can do once you go full screen is you can customize that. You can open all kinds of windows and do whatever you like. And now you've got your own private window configuration bound to full screen. What I do back in the office with my dual monitor is actually, when I go full screen, all the debugger windows jump to the other monitor. That's how I've got them, so I can glance at them while I'm in full screen mode. And then when I go out of full screen mode, they come and get docked at the right place. So here, to show you the multi-threading stuff, I just want to use the parallel stacks window, the parallel watch window, and I always have on the debug toolbar, obviously, and the debug location toolbar. I had that on in my earlier demos. I don't know if you noticed it there at the top. Always turn that on. It tells you where you are, which thread you're on. It tells you which call stack you're on. You can switch from here. So that's a good of what's my current context, which is so important to the debugger. The other thing I'm going to do is I'm going to go to the debug toolbar. I'm going to turn on show threads in source. And we'll see what that does in a minute. So what do we have here? We have the parallel stacks window. With one thread, it's basically like a call stack window. It just shows you where you are. We have the parallel watch window. With one thread, it just has a single thread entry, and you can go and add watches vertically. That's the difference. So there's not much there. I turned on show threads in source. You see where the yellow arrow is? That's where my thread is, right? So when I go and hover, because I've turned show threads in source, I can actually see what thread is there. With one thread, again, maybe not that interesting. So now let's go and generate multiple threads. The way I'm going to do that is by executing this line here, 34. And what that's going to do is going to force the execution of this query that I have here, this link query, that uses sParallel. And because of the sParallel, which is parallel link, what this is going to do under the covers is going to create multiple threads to execute this so it can complete, in theory, faster. So at that point, on line 29 is where we're going to go and get multiple threads created to go and help the main thread to perform this calculation. And the calculation basically calls one function, is prime, which I've got defined further down. Now, when I looked at this earlier, the results from my serial execution, what I noticed was that these were not all prime numbers, so clearly I have a bug. But even without a bug, I could have shown you the features. But I do have a bug. For example, 25 is not a prime number. So I want to go and debug the thread that's going to come in here where P is going to be 25. And that's where I can go and use conditional breakpoints. So I can go and use condition. That's the most popular advanced breakpoint we find from our telemetry. So maybe some of you have found it. And I can go here and say P equals 25. So by doing that, this breakpoint changes to have a plus. That's what all the advanced breakpoints do when they're breakpoints. Inside of it to show me it's an advanced one. And now when I continue debugging, and this is multi-threading, so I've got no idea where these threads are going to land, but we'll make it work. Because that's the point of multi-thread debugging. It's hard because you don't know where they're going to go. But I know one of them is going to be on that line, and it's going to be processing P, which is 25. So let's hit continue and see what happens. That's not too bad. So what we have now, let's look at these windows. What are they telling you? The parallel stacks window first. So the parallel stacks window shows you all the threads that have call stacks, so which are, I think, the most interesting ones. And what it shows is, so all the call stacks, in a way, it coalesces into, by using screen real estate efficiently, to give you a lot of information without taking a lot of space. So it says you've got 8 threads, and all of the 8 threads obviously started in external code. You're always going to have that down at the bottom. It's like your home. And then out of those 8 threads, one of them, which is this guy, went up that path. So it went into parClick, then it called parrot, then the anonymous method, which will be the isPrime, and then it went to isPrime itself. And this is the main thread. That's the call stack. And then 6 threads, they actually started in anonymous methods, and they went up to isPrime. So that's the coalescence that you're seeing there. And you get like a mini threads window in the pop-up when you hover over those things. So clearly 1 plus 6 is 7. So one other thread is still in external code. It is not walking up all the way. So that's the parallel stacks conveying you where your threads are in a single view. The parallel watch window, moving down, doesn't show you all the threads you have in flight. It shows you all the threads that are in the current function. So right now, I'm in isPrime. So it says these are all the threads that are over there. And the way you use this is not to compare based on call stacks, but to compare based on data. So I could go here and put P, as you saw earlier with our recursion example, and I can see the value of P across all of those. I'm in the wrong place. So let me switch here. So by the way, you can right-click here and switch to a thread directly from over here. Why is that not working? Let's see. All right. So yeah. So you can see P there across all of those different threads, and the one that I cared about was this one. So I can double-click and switch threads in the parallel watch window as well. So here with the show threads in source, you see how I can see all the threads that are on this line. So stacks everywhere, watch this function, show threads in source, this line. And if I had threads on different lines, that's the lack of the draw, you would have seen different thread markers, and I'm going to show you that in a second. So that's how these features kind of work. You can also go and do flagging. So I can say flag all threads below, and then I can show only flagged. So now I've changed my focus to just the threads I cared about. So you can go flag all the threads you care about and only work with them. And now let me give you a puzzle. The big thing with multi-threading, debugging, what's really challenging is that the scheduler can do whatever it likes, right? So the threads can go wherever they want. So you're stepping and you don't know where everything is. You have to reevaluate every time, hunt and find. So when you're trying to debug multi-threaded issues, you want to be the scheduler yourself. You want to simulate situations. Get this guy here, get this thread over there, get them all on this line, that kind of thing. So how would you get all the threads on line 58? If I wanted to just do something in the debugger to get them all right there so I could compare values across the board. Anybody know? I said no. Do you want to know? Yeah, all right. Just checking. So if you right-click here, you can actually use run flagged threads to cursor. So just flag the threads that you know are going to go past the point. And when you do that, we will let the threads run. And when they reach that point, we will stop them there until all of them have reached that point. And only then we will break and present the state to you. So let's make it some more difficult here. So I don't want to bring all of them. So let me go and flag every single thread. But I don't want to do all of them, let's say. Let's say, I'm just making up scenarios now. Let's say I don't want to bring this thread. So then I can unflag it, right? But if I do run flag threads to cursor, that thread is going to go wherever it's going to go, right? You just don't know. What if I want to say I want to bring all of them there, but not that thread? I want that thread to stay where it is. Then what I can do is I can go and freeze it from any of these places. So I'll do it here. So I can go and say freeze. So now I have frozen that thread in place, and I can take all the other threads and bring them here by doing run flag threads to cursor. And by doing that, you can see that I've got here the 7 threads, and I can see which one is the current one that were flagged. And then you see on 41 the thread marker. That's what show threads in source gives you. And when I hover over that, I can see that that's where I have the other thread that stayed. So that's how you can control and let threads be where they are. So if I want it here to say, actually, I want now to step this guy, so I'm going to need to switch to it. And I'm going to need to thaw it. But then I want the other threads to stay where they are. Well, I'll just right-click there, and I'm just going to freeze all of these. And now when I go and step, I'm stepping this one thread. I can put breakpoints and treat this as single-threaded debugging. I found the thread I want to focus on, while the others I know are staying put. And I can go and compare values here in the parallel watch window and so on and so forth. So those are basically I think the key debugging features for multi-threaded. Freezing, thawing, flagging, using these windows, using show threads in source. Just in case you were wondering about the bug, it's basically over here, and I can go and add I as well. And you'll see that when I go and step, I go into the iteration, but then here, when I step over this, I is going to become 5. I can see that here, and I can see in the tooltip the old value was 3. And that means that this condition over here is false, which means we're never going to reach this point where 25% 5 gives us a remainder of 0, which means we're never going to get ret be false. It's going to remain true. And that's what happens over here, just in case you're wondering what the bug was with this prime. So really what I need to do is make that be smaller or equals to, and I will have found the bug. So those are our multi-threading features. Did you like those? Think they're good? I think I've already summarized all of those. I didn't talk about filter breakpoint. I'll very quickly show you that as well. I don't want you guys to miss out on anything, because I don't want to miss out on the evaluation in the end. Hint. So filter breakpoints, if you know the threads you're dealing with, you're creating them yourself, unlike my scenario where they were created for me under the covers. You can go on the filter and actually set its thread ID, if you know that, you found it at runtime, or give them names, and then you can break on a name. So that's how you can create filtered breakpoints, and then that thread breaks. So it's equivalent to conditional, but based on the thread characteristics rather than data characteristics. So that was that. That wasn't too hard. So remember I said if we have time, we're going to get to see 10 slides with 10 more tips. You're going to get to see 10 slides with 10 more tips, because we have time. All right, so let's go through these fairly quickly. So I showed you earlier the support for async in the call stack window, where we saw the async call. We also have the tasks window, which we introduced in VS 2010. We called it parallel tasks. So now we've renamed it, so a lot of value there already. And we've renamed it, and now it can also show you async operations. So call stack window answers, how did I get here? Like what queued up this async operation? The task window answers, what async operations do I have in flight? What else is happening that hasn't completed yet? So you can open that, and you can see those in a row and switch them and see where they are right now or where they started from. And for these, and you've noticed probably earlier on the slides, I have URLs at the bottom when you get the deck. Those point to our blog. We blog about everything new that we introduced, so this is new. Pseudo variables. This is not new. This is old. So you could go in the watch window and put $ and then some characters, which are predefined, and that creates a pseudo variable, not a real variable. For example, you can put $user, and then you get to see all kinds of information about the current user account. Now that we've added return values in the autos window that I showed you, we introduced the pseudo variable $return value. So you can go and use that in the watch window if that's where you have all your watches and you want to keep an eye on what gets returned. So read the documentation if you don't know about these, especially for C++, there are a ton that you can go and use, but also for .NET. Format specifiers. So again, in the watch window, you can put a comma and then put whatever magic characters we have predefined, and that's how you specify different formats or a different thing to happen with the expression in question. So for example, instead of toggling globally, hexadecimal and decimal, you can do it per variable basis, comma D or comma H. One of my favorites for managed code is AC. You know, whenever you have to enumerate something, you always have to hit the refresh to get the stuff out. AC will just force it to happen. So it will allow changes automatically without you having to hit the refresh button. So if you know what you're doing, that's something you can use. And you can see a bunch of others. Again, in C++, there are many of these. If you are using C++, and you have pointers that are really arrays, you can put a comma and then the number of elements that you're interested in, so comma 4, and then you'll be able to expand in the watch window and see those. Now, if you want that in a data type, then you can go in the registry and change offer array expansion to 1, and this is unsupported, but I'm sharing it anyway because I like you guys, and then you'll be able to look at the data type, all the elements that you want. If you're writing mixed code, you're mixing languages. If you're mixing native and managed, we have mixed debugging for those. We've had that for a while. Now we've added JavaScript and native. So if you want your debugger to swing both ways, that way you can go and enable that by choosing native with script, and that's going to enable debugging both sides. So you'll be able to hit breakpoints across them and so on. Again, for my C++ friends in the project properties, unless you're actually debugging the heap itself, you can go and put _no debug heap equals 1. That will speed up your actual debugging. So it's going to be faster. So just go and do that without thinking about it. And then the other bold thing I have is there's a new accelerator for those doing GPU debugging. If you didn't know, you can actually debug not just your CPU code, but your GPU code in C++. And I have a screencast of 15 minutes showing you all our GPU debugging capabilities, if that is of interest to you. Data breakpoints in C++. You can put an actual address or put ampersand on your variable, and we'll figure out the address. And then every time you access that, we'll just break. In .NET, you can do that with properties. You can simulate it. But if you really want that feature, use Visual Studio User Voice to vote for it. And the CLR team will work with us so we can offer this to .NET developers as well. I talked about visualizers in .NET. If you're doing C++, the AutoExp.dat is the old way. The new way as of VS 2012 is to use NatVis, so read them as the end documentation on how to use that. And you know, earlier I showed the trace point, and a few of you kind of had heard about it. I bet you didn't know you can customize the default message that comes up. You saw how in my code it said moth equals something every time I created a new one? That's in the registry again. So you go in and change that registry location. When you get the slides, you can see it, and you can change the default message to be something friendlier to you. And then this is an interesting one. Did you know breakpoints can make a sound? So you can go to your sounds and then choose Visual Studio and choose a sound for it. So that's useful if you put a breakpoint, it's going to take a long time to hit, and you want to do something else. You do something else, then you hear the sound, and you're back at it. It's also a great prank to play on your colleagues at work when they're not looking to use various sounds for the breakpoints. So that was 10 slides, 10 tips, but I really like you guys. I've got an 11th one here. So hopefully you know that you can do debug attach and attach to a running process so you can debug it. But what if you have an exe that you want to debug its startup path and you don't have a project? Well, did you know you can go File, Open Project, and point it to an exe, and we will create an exe project properties for you. You'll see what you're seeing on the screen. And you can configure the debug engine and other things, environment variables and so on, and then hit a 5, and we'll start up the exe with you attached to it. So that can be really useful when you need that kind of thing. And if you're a command line junkie, devenv/debug exe, and the path to your exe would also do the same thing. So with that, I'm going to need a minute to summarize, but before I take that minute, a couple of pointers. On Wednesday, my colleague from the diagnostics team, Andrew Hall, is going to be talking about how diagnosis is in production environments. And if you look at the sub-bullets there, you'll see I didn't touch any of those topics. And that's because we designed our sessions to be complementary. There's no overlap. So that's a great session for you to go and see more debugger tips, in particular as they pertain to production environments. And then on Thursday, we're doing a joint session, the two of us. In the first part, I'll show you some device-specific debugging. So I've kept a few tips back from here to show them there, but also I'm going to repeat some of them. So that first half may be interesting, maybe not, specific to phone. But the second part of that, Andrew will be showing you the Performance and Diagnostics Hub, which is awesome, a new feature for Windows Store and Windows Phone apps only at the moment. And that helps you with diagnosing performance issues, not correctness issues. The other pointer I have is our user experience team is here. So Carl here in the front with a hat. You can go sign up with him for 2 different sessions we have where you can give us feedback on our plans for future versions or bring us your hard problems to diagnose. So take note of those. And then I'll take my 30 seconds to summarize. So I'm not going to summarize all the tips that we just saw. I'm not going to present this slide to you. I'm not expecting you to read all of the slide either. The reason I put all that there is for when you get the deck. And you can see the 60-plus things that I've shared with you today. And as you look at those and find your favorites, the one you go back to share with others, and you have that warm, fuzzy feeling of having learned something new and useful, that's the feeling I want you to have when you complete my evaluation form for this session. When you go and look at these, if you find like your favorite tip that you learned today, put it in the comments. Just let me know, so then I'll know that's the one I need to like big up next time I do this session. If you have a tip that I didn't share today around debugging, put it in the comments. So I read every single comment. So please use the comments to convey that information to me, in addition to giving me your top score, of course. And I hear when you complete evaluation forms, the higher the mark, the more chances of you winning this. I don't know who started that rumor, but that's what it is. So please do that. Thank you very much for staying with me for the whole time. Really appreciate your time. Thank you. I can make sure that you know more about the debugger, more about the tool than anyone else when you go back to your workplace, from your colleagues, your manager, whoever you work with. After this session, you will know more about the Visual Studio Debugger and how to make the best of it than any of those folks. And from day one, from your first debugging session, you'll be able to apply some of the things in order to cut the time you spend there. It's all about saving time, being a power user of the debugger. So that's what I plan to do here. Is that a good deal? Does that work for you? Yeah? All right. So how are we going to do that? We're going to do it like this. I'm going to spend 60 minutes in Visual Studio. So those of you in the back, there's going to be a lot of Visual Studio in code. I've got big fonts, but if your eyesight is not all up there, you probably want to move forward. There's going to be a lot of Visual Studio here. And at the end of the 60-minute demo, if we have time, because I like you already, I'm going to throw in probably 10 slides with 10 tips on each one. If we don't get to that, don't worry, when you get the deck, they're pretty self-explanatory. You'll be able to get those extra bonus 10 tips. So that's how we're going to do it. And before we go to the demo, let's start with 3 slides and 3 new things in Visual Studio 2013 to set up the pace before we jump into Visual Studio. So the first thing is just my code. How many people in here know what just my code is? Can I have a show of hands? It's very few of you, and that's fine, because by default, this just works for you, and you don't have to know about it as a .NET developer. The cool thing is, what's new, is that now C++ and JavaScript developers can also benefit from this in VS 2013. What it does is it basically hides code that you don't care about, because it's not your code. So we've got some rules that you can read up there about how we determine which code is not yours, so you don't have to have that visual noise there, you don't have to accidentally step into code that you don't care about. But joking apart, I've been here for a couple of days now, and I do like it, because compared to Seattle, where I traveled from, when you look up in the sky, there's this bright yellow, round thing. I think it's called the sun. So I like that already. And those of you that have been to Seattle know what I'm talking about. So I know you're not here to hear tips about Houston. You're here to see tips about the Visual Studio Debugger. And judging by the hundreds of you that have turned up, I don't think I need to motivate why this is important and why we should be talking about it. But I will anyway. So what I did is I went online and searched for quotes around debugging. And I found 3 that resonated with me. And I'd like to invite you to just take 20 seconds to just read them. Essentially, it boils down to this. You want to ship quality code fast. That's what you want to do as developers. And the debugger can help you by eliminating bugs, and it can help with the quality parts. But really, if you think about it, the less time you spend in trying to find and fix bugs, the more time you can spend adding value, adding features to the code that you ship. So being good at debugging is equally good to being good to writing code in the first place. Now, it takes talent and experience to be good at diagnosing root causes. And that I cannot give you today here. But I do know that if you take two equally experienced and talented people to try and find a problem, and one of them knows the tools better, that's the person that's going to find it faster, that's the person that's going to win. And that's what I can do for you here today. I can make you be that person that wins. All languages and other kinds of platforms. So a very simple app here. It doesn't do anything interesting. You can see I'm in design mode here. 2 classes is all we're going to be looking at. And when I run it up, it's just an app with big buttons. I figured today there's touch screens everywhere, so I'll make my buttons big. You never know when I want to use my forehead to touch a button, so I need a big target. Yeah, that's the level of jokes, by the way, we'll have here. You can cringe, you know, smile, do whatever. So, so you saw there that I hit a 5 to start debugging. Hopefully everyone knows that. But did you know that you can actually start debugging just by stepping into your app? So you can go and hit F11 or F10, and you can step into, and that takes you out of design mode into debug mode on the first line of your code that's going to execute. So, and then from here, if I was to go and continue stepping, of course, it's going to go into the constructor of my class. It's hit my field initializer. And now it's going to hit the field initializers of this other class, and then I can step there. I don't have an explicit constructor here, so it's going to step back out, and then I step into this constructor, and so on and so forth. So let's talk a bit more about this tip. I won't do this for all of them, just so you can get the idea. So why is this useful? It's useful if you're trying to debug startup issues. How would you have done it otherwise? You would have had to go find what was the first line in your application that was going to execute, put a breakpoint, then hit a 5, hit the breakpoint, then remember to remove the breakpoint because you don't need it anymore for later, and you would have solved your problem. So what does this do for you? It saves you time. That's the theme. All of the tips I'm going to show you, there would have been another way to achieve what you want, but these save you time. So you can step to start debugging. Now, what I wanted to do here is I wanted to go into a function so I can show you some stuff, and that function is actually demoviz. So I could step into demoviz, and I want to go all the way to the end down here. So instead, of course, doing all that stepping, what can I do? Hello, everybody. I hope you enjoyed the keynote and you chose your foundational session wisely. Welcome to the first breakout session here at TechEd in Houston. I want to thank you in advance for choosing to spend the next 75 minutes of your life here with me. I hope to make that a good return on your time investment. And as you can read on the slide, my name is Daniel Moth. Originally, I come from Greece in Europe, and when I was around 20 years old, I moved to the UK, where I spent around 15 years, including working as a software developer for a few companies. And then around 6 years ago, I moved to the States, to Washington State, specifically in Seattle, to join Microsoft and the Visual Studio team. And that's where I am still now, on the Visual Studio Diagnostics team. I like to travel, so I was really excited when I was invited to come down here and speak, because I've never been to Houston before. This is my first time. In fact, I'm curious, by a show of hands, how many people this is your first time in Houston? Can I see that? It's quite a few. If you look around you, the people that didn't put their hands up, those are the ones you want to talk to for tips about what to do over here. And I happened to be in that situation, actually, around 3 months ago. I was doing an interview, trying to hire someone for my team, and they were actually from Houston, so they live and work here. So I took the opportunity and I asked them. I said, hey, I'm going to be in Houston in May. You know, what is it to do there? What is it to see? And he said, like, you're going to have a ton of fun over there. There's a lot to see. There's a lot to do. And I'm like, this is great. So tell me more. Like, what's the top thing? You know, what's the top attraction, the top thing I can do when I go to Houston? And he said, well, you can drive 2 hours to Austin, and it's an amazing place. I'm like, great. So based on that account, the best thing about Houston is that it's close to Austin and all that kind of stuff. So it lets you focus and hence find the solution faster. You're going to see a bit of this in action when I go to the demo, but now we also support it for C++ and JavaScript. The second thing is the modules window. And I know that not everybody uses the modules window, but when you do need to debug something to do with symbol loading or with finding the right module, the modules window is indispensable. And we've now added a search capability. To be honest, we did not add this for you, although you can benefit from it. We added for our own developers. This is what Visual Studio looks like when you attach to it. You see the little scroll bar? That's how many modules are in there, so search was pretty important. As an aside, following on from the previous slides, and since most of you said you were not familiar with Just My Code, if you're curious which part of your application in terms of modules we treated as your code versus not, you can find out by going to the modules window and looking under the user column and seeing yes or no, and looking at whether we thought it was optimized or the symbols were there and so on. So that's the second thing. We've got now search support in modules. The third thing is that .NET Framework source stepping now works. We've had this feature out for a while, but it wasn't really working correctly all the time due to the frequent releases of the .NET Framework without a corresponding source release. You can go to the URLs that I've got up there when you get the slides to read more about it. But do note, when you use this, you have to turn Just My Code off. So you're trading off that. I personally do not find this useful for my everyday debugging. I find it very useful for using the debugger, the best tool in VS, in my opinion, to understand how the framework is implemented, the .NET Framework, by stepping into the various methods. So use it as an exploration tool rather than a debugging tool, in my opinion. So those were the quick 3 things. And now let's go and have a look at Visual Studio. So I'm going to be using here a WPF application, but it doesn't matter. Most of the tips apply to